Hey, in this video, we're going to be talking about specific heat capacity in this concept and context. We're going to do a problem where we look at heat transfer between two substances, and we're going to connect that to what we learned in our calorimetry video about how heat is calculated, and apply that to this situation or context in which we're looking at heat transfer between two substances. So let's get right into the problem. So we've got our problem here, which says a 150-gram sample of a metal at 75 degrees Celsius is added to 150 grams of water, or H2O, at 15 degrees Celsius. The temperature of the water rises to 18.3 degrees Celsius, and we're asked to calculate the specific heat capacity of the metal. I'm going to underline that, the specific heat capacity of the metal, assuming that all the heat lost by the metal is gained by the water. All right, so I'm going to do two things before we jump into the problem, just to help us get an understanding of what we're dealing with. So I'm going to draw this diagram here. I like to do this because it helps me to keep my information straight. So we've got the water here. Beginning this exchange of heat at 15 degrees Celsius. And the metal is beginning this exchange at 75 degrees Celsius. Now, this isn't going to be to scale, but we see a final temperature for the water of 18.3 degrees Celsius. Now, this can be kind of confusing because you might ask yourself, okay, well, I know from calorimetry, in order to calculate heat, I need a change in energy. Calorimetry, in order to calculate heat, I need a change in energy. I can calculate a change in temperature, and then therefore, and that will allow me to calculate a change in heat, all right, the heat of the water. Let me draw that a little bit differently. W instead of H. But what about the metal, right? What temperature did the metal finish that heat exchange at? Because the metal is inserted into the water or added to the water, it becomes part of that system now, right? And so that system is going to equilibrate to that same temperature, which means now that system, which is in the kind of state 2, is water plus metal. That's one system now. We're going to see that the change in temperature for the metal, now allows us to calculate a heat for the metal. Now, when we assume that all the heat lost by the metal is gained by the water, what that's really saying is that our heat from the water plus our heat from the metal should be equal to 0. And so therefore, Q of the water is going to be equal to the opposite value of the heat of the metal. Okay, this is actually going to be very, very important to the rest of the stuff that we do here. Just for your reference, Q in this case, our reference equation is MC delta T. We're dealing with specific heat capacities in this case. All right, so we've got our heat of the water is going to be equal to 150 grams of that water. Okay, we're going to take the specific heat capacity of water, which is 4.18 joules per gram Celsius, and then we've got a temperature change, which is going to be final minus initial. So we've got final, right? Final minus initial, all right? So that's 18.3 minus 15.0 degrees Celsius. We'll notice here that degrees Celsius are going to cancel from here and here when we multiply across. Grams and grams are going to cancel, leaving us with joules on this side. We're going to set that whole expression equal to 150 grams of the metal. All right. Our specific heat capacity of the metal, which we're looking to calculate, and then we're multiplying that by the change in the change in temperature of the metal. So we're going to go final minus initial again. All right. Noticing that our final temperature is that 18.3 degrees Celsius. So we're going to do final. I'm not going to put that there. Final minus, just a moment. Final minus initial. Okay. Now, what's very interesting, what I'd like to say here, hopefully this doesn't add too much here. The units for specific heat capacity are joules per gram Celsius. And so we can see here, we're going to get us a value for the specific heat capacity of the metal, but it's important to realize that we've got grams here, and we're going to cancel grams in terms of units. We've got Celsius here, and we're going to cancel Celsius in terms of units, and that's going to leave us with joules. And so by the end, what we'll see is that we have joules on this side and joules on this side. So we're good. We've got all the information that we need. Now, what I'm going to do here is move these values over. So what we're going to have to do is divide both sides by 150 grams, and then also divide by the change in temperature. Okay. I'm going to do that on both sides here. So now what we see here, we cancel this, these cancel as well. Now, what we've got here, right? We remember we talked about how when you cancel the units up here in the numerator of the fraction, right? We get joules. And we remember that specific heat capacity is, the units for specific heat capacity are joules per gram Celsius. When we find the value of joules up here, we're going to divide that in terms of units by grams per degree Celsius, and we're going to get a specific heat capacity again. All right. So go ahead and plug in these values, right? Do the math, and you'll find the value for the specific heat capacity of the metal. But what we want to demonstrate here is that we're using our equation for heat when it comes to calorimetry, right? And that's going to come in a number of different flavors depending on your situation and the information that's given to you. But we also see here that units are very important for calculating these specific heat capacity, calorimetry related problems, because if we don't have our units correct, we may end up getting an answer that doesn't really fit the situation, or it's not very reasonable. All right. So once again, we kind of went through some things. We used this little diagram to come to understand that we've come to this new state where the water and the metal are assumed to equilibrate to the same temperature. We use our equation, right, from calorimetry, and then we kind of take note and use this thing called dimensional analysis, where we're making sure we pay attention to the units in order to make sure that we come to the right values at the end. All right, so hope you guys learned a couple of different things from this video. that you're a little bit more comfortable with calculating different kinds of values that are related to the concept of calorimetry. I'll see you in another video. All right, bye-bye.